Relocate, a simple training-free baseline for visual query localization using region-based representations. Visual query localization is the task of finding when and where an object last appears in a long video, given a reference image. In essence, it's like querying episodic memory with visual prompts. This task has several applications such as smart surveillance, assistive tech for visually impaired, wildlife monitoring, and autonomous navigation. The task presents several challenges for the contemporary computer vision systems. For instance, unlike classic object detection models that are trained to identify a fixed set of object categories, VQL requires localizing an open-ended range of objects. Additionally, the object's appearance may vary significantly from the visual query due to changes in orientation, scale, context, lighting, motion blur, and occlusions. Compounding these issues, the object of interest usually appears briefly in a long untrimmed video, making this a needle in a haystack problem. To address this task, we propose a stage-wise pipeline that uses region-based representations derived from SAM and Dino. The proposed pipeline works as follows. In stage 1, we generate region-based representations for every object in every frame of the video. To do this, we use SAM to segment frames into object masks and Dino to extract frame-level features. Then, for each mask, we average pool the features inside the region to create a single token representing that object. This is a resource-intensive step, but it only needs to be done once per video. The representations can be cached for fast and efficient querying of multiple objects. In stage 2, we search the given query in the video. Specifically, we extract a region-based representation for the query using the same process as in prepare and compute cosine similarity between the query token and all region tokens from the video. We use this similarity score to select high-scoring candidate regions that are likely matches for the query. In stage 3, we refine the selected candidates. Specifically, we crop a high-resolution region around the candidate and extract refined region tokens from this zoomed-in view. We then recompute the cosine similarity between these refined tokens and the refined query token. This step helps eliminate false positives from the initial search and improves precision of the bounding boxes by taking a closer look at each candidate. In the fourth stage, we track the selected candidate across video frames to get a response track. For this, we use SAM2. Finally, in stage 5, we generate new visual queries from the initial response track. These queries capture the object from diverse viewpoints, helping us handle occlusion and appearance changes. We then repeat the search, refine, and track steps using the expanded query set, increasing the chances of retrieving the latest appearance of the object. We evaluate relocate on the challenging EGO 4D VQ2D benchmark and achieve a 49% relative improvement in spatiotemporal average precision over the previous best method. Notably, we do not perform any task-specific training and still vastly outperform task-specific methods. Our work highlights the strengths of region-based representation over traditional patch-based representations. As shown in the table, using regions produces 24 times fewer tokens, making it far more scalable for long videos. Moreover, the region count is resolution independent, which can allow us to leverage high resolution inputs without sacrificing scalability. Region-based tokens also offer better spatial localization as seen in the cosine similarity heat map. Next, we take a quick look at the ablation experiments. The table shows the impact of the refinement stage. Removing it from the pipeline causes spatiotemporal average precision to drop from 0.333 to 0.246, highlighting its importance. Essentially, by taking a closer look at the selected candidates, the refine step helps produce more precise bounding boxes and filters out false positives from the initial search results. This slide highlights the impact of query expansion and reiteration, which significantly boosts performance. Relying solely on the initial query can miss the last appearance due to occlusion, viewpoint changes, or partial visibility. By generating new queries from earlier matches and repeating the pipeline, we improve retrieval of these challenging final instances. For more details, check out our paper. Thank you.